Hi, welcome to the Cluster API, Kubernetes Cluster API breakout session for November 8th, Wednesday, November 8th, 2017. We're going to get started. I'm looking at the agenda right now. So first up, Chris with control plane API updates.
Hi, so just as a quick update, I have updated the PR with all the feedback. I received a lot of feedback regarding why this setting is here and that setting is not. Some of that was taken away, the cluster object had a overall version, and just at a quick glance that seemed fine, but thinking more and more about it, it was better to move that to the individual master machines so you could do per master upgrades and affect it that way. And in an HA scenario, if you're doing a rolling upgrade, one overall version doesn't make sense. Other questions were like, why isn't this setting here, that setting there? I just want to note that the approach to this is purposefully minimal for now. The initial use cases are basically create, upgrade, and delete a cluster. And stretch goals are like expand to HA from single master, but I don't think we're going to, I want the API to be able to express that, but maybe no implementation addresses that for this quarter at least. And I believe Justin Santa Barbara also brought up a very good point of why can't we just reuse component config? And that is a very good point and approaches something I want to discuss. I would very much like this not to duplicate anything in component config unless absolutely necessary. I mean, I think it would be a great use case if we could just do a deploy of a cluster, and any of the dynamic knobs and tweaks that are in component config, you could just apply later. As an example, one thing that is in component config that I did pull out were like the service network siders and the pod siders, because those often require a cloud provider specific setup with either GCP advanced networking, AWS, I think you could use Flannel there, or some sort of network provider. And those are often not dynamic settings. Those require cloud provider intervention. But other than that, all the current feedback has been addressed. If you are interested and want to debate whether something should be there or not, please go look at it and respond. I'll add a link to the notes of the actual PR and review. And I did check the current review status in to a different location, just so prototypes can start using it.
Cool. Does anyone have questions for Chris on that, or any discussion to happen, or should we just move on?
I had one quick question. So regarding the cloud provider specific information, where would that likely be stored? So if we want to provision a cluster and have specific network settings to be applied to it, where would that fit in?
So both the cluster and machine objects have a provider config field, which we are suggesting be at this point be a serialized string of some structured data that is specific. So AWS could have an AWS config struct that had individual settings there. GCE could have one. There's some debate on whether just a raw string is the right format, but there is going to be some sort of hook inside of each one, both cluster and machine, to provide cloud provider specific overrides.
And if I need to install, let's say, Istio and configure Istio as something that's like an add-on extension to my cluster, would that be the appropriate place to do it as well?
I am hoping Istio you could install via kubectl create, as with like most add-ons can be managed through the actual Kubernetes API.
Oh, okay. So add-ons are not necessarily part of the cluster API scope right now?
Only yes and no, in that essential add-ons are like kubeproxy and kubedns.
Right.
Anything above and beyond that, I don't think we should target, and maybe an add-on management solution dedicated to that should address that.
Okay.
One of the things that we do right now in the prototype installer is after we stand up the cluster and create all of the essential things, the installer takes these YAML files that can contain as many objects as you want, and we shove it in the API server as real API objects. So we could, I don't know if we actually do validation to make sure that they are supported types that we are expecting, but if we're moving in the direction of allowing you to specify the component config for your components as well, you would have your main, here's my cluster object, here are machine objects, and then here's some component config for the components that I care to configure, and then you could also just have here are the add-ons, and it would kind of save you the step of having to do kubectl create. It would just shove them directly in the API server.
I had one follow-up question sort of related to the cloud provider specific stuff. As part of the Machines API, I get that we're going to be able to stamp out nodes, but what about the extra cloud resources that I need, like load balancers or firewall rules or things like that? Is that going to be a part of the Machines API or something separate?
So I would say it's separate from the Machines API. To me, it doesn't really, I don't think it makes sense there. It could be part of the provider config of the cluster object, or it could be an implementation detail. So the pattern that we expect for all of these is anything that we don't think we can generalize right out of the gate should go somewhere into the provider config. And then if we find that everyone who is supporting the cluster API keeps using the same kind of configuration in their provider config and it's generalizable enough, then it can go through kind of a graduation process to be part of the proper API type. But if you, so let's say like GCE, if you wanted to use this to create a GCE cluster, we could just say, if you want your masters to be behind a load balancer or something, instead of just hitting the raw IPs, that's an implementation detail. And it's up to the installer to figure out the best way to support the rest of the configuration that you've defined. And if it decides that you're in a multi-master situation and you should use a load balancer, it can do that, and it should be transparent to you. But if we also want the flexibility of allowing you to specify, I definitely want a load balancer or I definitely don't want one, that since that would be a cloud-specific thing, that we would then put that as some key in the provider config right now. And then again, like every provider config has the same exact configuration, then we just bubble it up to the API type.
To maybe concretely address this, one of the few settings in the actual cluster object right now are the pod siders and service siders, and those often require special networking configuration. What it is it's a generic config inside the cluster for every cluster, these siders, and the provider can interpret that to build whatever objects they need. So in GCE, we would build subnetworks for these things. In some other configuration, you might set up a flannel network provider and build, what do they call those? Overlay networks for these siders, depending on what your provider setup wants to do. And as far as like load balancers and stuff, like if you define multiple masters, the cluster status has a list of API endpoints, and the cluster provider could just like for each master put an API endpoint in there if it wanted to support client-side load balancing. But it could just as well create a load balancer and put only one API endpoint that load balances to all masters in there.
Okay, thanks.
Yeah, one of the other kind of guiding principles, I don't know if we've explicitly said this before, but since we're in cluster lifecycle, well, a lot of us are in cluster lifecycle, we've been thinking about for what goes in the API, is it something that I really need to know at installation time or something that we want to change over time as part of cluster operations? So if there's something that is really necessary to need only at installation time, and it's something that you should never change or could never change just by changing a field in an API object and having it be reconciled, then maybe that's just an installer flag. But then under the covers, it doesn't actually have to be attached to the API object, because if someone changes it, but like there's no value expressing it in the API. It would just be a purely installation level thing. Yeah, I don't know if that's completely agreed upon, but that's how we've been thinking about things. What actually needs to change over time, and what kind of tooling do we want to build on top of the API versus what is all of the power that everyone's going to want to use to configure every little bit of the cluster. Cool. Anything else on the control plane API or any of the recent updates on Chris's PR, or we can move on? Okay, next agenda item was mine. This is something that's come up in my PR for the Machines API. And when I first started with the Machines API a while ago, in the status of the machine, I used a phase because a lot of our statuses had phases, and then found out those were completely deprecated because people tend to use them as a state machine, and that's very brittle for API evolution. So I changed to a list of conditions, and then found out that those are being deprecated. They're not fully deprecated now, but it's considered to be an anti-pattern that's not generally useful. So the recommendation from Eric Toon and Brian Grant was, in the status, just have top-level fields, not a list of like state changes, but just top-level fields that indicate meaningful status. And so the simplification we have right now, in at least in the field status, is we have an object reference to the node, if a node exists for this. We have an enumerated error, so something that is meaningful for an actual process to interpret, and then a human readable error, so like a reason and message, which conditions used to have. And then we have this kind of giant bool of ready. Am I ready or am I not ready? And I'm wondering if anyone has thought through or perceives the need for more granular status updates to say, like, well, I've rectified or I've reconciled the kubelet version, but not the version of Docker, or I've created the VM, but it's not completely ready, or things like that. Because right now, in starting very simple and trying to have something very minimalistic, it's just, am I ready or not? And if you need more power, you can always look at the object reference and traverse to the node and look at its status and actually compare fields from the machine spec to the node. If you actually care, like, do the versions match right now? Otherwise, the expected workflow for any tooling that wants to create or modify a machine is you touch the object and change its spec, and then you just watch the status and wait for the ready to become true, and then you move on. You assume it's completely successful.
I guess I'm just curious as how you define complete success.
Good question. My definition of success, and this comes from the idea that the API is so simple right now that in our prototype we have a single controller that's responsible for everything so far. Maybe it makes sense once we have multiple controllers that are reconciling different parts of the spec to call out their statuses separately. But right now, if realistically the entire spec is matches reality, the controller would set ready to true. And on any single update to the spec, as soon as the controller notices, it would set the status back to false until it rectifies. And it could swap out the VM for a brand new one, or something else can trigger an in-place upgrade or something. But the very next time it looks at the real world and compares it to the spec, and it matches fully, then it just sets ready back to true.
So in that scenario, you have multiple controllers with different ideas of ready and not knowing how the others are going to agree it's ready.
Potentially. Like, the simplification comes from the fact that we just have a single controller right now, and I don't know at what point we'll want different controllers to be responsible for different things. So another option is, like I said, like if you just updated, let's say, the kubelet version, you're writing an upgrade tool and you upgrade the version of the kubelet, you can watch not only the ready field, but you can watch the node object and actually verify that its reported kubelet version matches what you expect it to be before moving on when it's successful.
Yeah. I agree. Yeah, I think generally it's the tool's responsibility to make sure everything's consistent, right? So the ready state in the API, I think it's just one of the signals the tooling should be take into the consideration when he make any decision.
Yeah, I ran into this same discussion with the control plane API. I was like, what does ready exactly mean? And I thought that is actually a difficult question to answer. But I erred on the side of, let's just remove this flat Boolean, keep all the error messages and error statuses, and also, if you need to inspect the API, as API endpoints become available, like you can connect to them, I populate the API endpoint status, and then you can go inspect the API component statuses to see what's there. Because I honestly did not know the best way to reconcile a top-level ready state, and I would rather not have it until we're sure what it means.
Yeah, I think it's completely fair. Maybe we should just set the standard that we don't have. Like, it's perfectly fine to keep the errors because that's reasonable to interpret, and it's not. I don't think it's terribly bad if one controller overwrites the error of another controller or something like that. But yeah, maybe we don't want the pattern of just watch this bool. The pattern should be for the thing you care about, actually check the status and make sure that it matches the spec, and that's when you determine that you're done. I think that's a good simplification.
Sorry, one thing that at least when we tried the API internally and from our experience was that every single controller can, or provider actually can create arbitrary amount of, for example, resources in the cloud provider. So, and I currently didn't find anything in the API status where we can put those things. So I think we should have something there, or I don't know.
Yeah, I think I saw your PR comment, and sorry I haven't gotten through addressing everyone's comments on that yet. Yeah, so I have kind of two answers to this, and one is in our prototype that we've been working on so far, I've started just using annotations, because you could just slap key value pairs on any object and represent whatever arbitrary state you want without type safety or anything. Because if it's going to be provider specific, then it doesn't seem like it should be in the API proper. But I wonder if you're asking or you're reading into this a little bit, do you want something similar to the provider config, but in the status field? So you could have some more structured data there and say, here's, for someone who understands my provider, here's all of the information you might want to know about.
Yeah, more the second kind with the like a cloud provider with the in such field, so structured data, more or less.
Yeah. Can we dive into that use case? Like, is there tooling that you think would want to read those specific fields, or is it more you want a convenient place to store state without having to worry about an external state store?
The latter, actually.
Okay. Well, so then, yeah. So, I mean, it doesn't really feel like a status then, I guess. I don't know. So, I mean, other people can object. It seems like I update the spec as a client. I update the spec, and so the status exists, so I can follow along the progress toward the spec being reconciled. If this is something that only the controller is going to use, like the provider controller, and it's just I won't call it laziness, because I actually think it's a good place to store state. Like, we already have an entire state machine, might as well put more state in there. But I don't know. It seems like you could get by with annotations and other things, or you could create like an entirely different API object, just like a config map or something that's just for your provider, and it doesn't have to be attached to that machine. There could be a link between the two if you want. Like, you could have an object ref back to the machine. I don't know. So are you leaning toward you'd like to have more structured data, and it should be somewhat expressible within the machine object?
I mean, if you have structured data, it will be easier. We have type safety and etc. So it feels more natural. But yeah, there should be a balance between extensibility and general availability of the API. So yeah.
In my mind, it seems like that could be a completely separate config map with a reference, or just key value annotations. But I know that is an interesting use case. I'll have to think more about that. I don't have a really great answer right.
I think the answer at this point is it's provider implementation detail. Feel free to use annotations, custom API groups, your own CRD with API object references and finalizers if you need them. But as if a pattern emerges that turns out to be useful for everyone, we'll certainly consider it.
Yeah, I think that sounds reasonable.
Okay, great. Thanks.
Cool. Let's see. Oh, yeah. So I just want to do a check-in. We don't have many agenda items, so if anyone has more things, feel free to add to the agenda or interject right now. But our team at Google has been prototyping an installer and reconciler to actually exercise the API types and make sure that we've covered edge cases and things. And so I don't have a demo ready, but we can talk about its current status. And I think Ajit's on the call. Ajit wrote the installer and has made recent changes to it. So Ajit, if you are able to talk to it, can you talk about the current status of the installer and what it's capable of doing and kind of where we're at generally?
Yeah, sure. So currently installer works only for Google Cloud Provider. I have not added implementation for others at the moment. I believe people can add their own implementation, and it should not be difficult to add your own implementation the way it has been written at the moment. So it takes your cluster definition and the machines. So you provide like master machine definition and other nodes you want to join in the cluster. Based on that, it creates a cluster on GCP and creates machines custom resource definition and schedules machine controller pod on the master VM itself. So Jacob wrote most of the machine controller part just to add. So, and machine controller watches all the machine CRD definitions, and whenever there's an add or update, it looks and reconciles. So if you have to add more nodes to the cluster, you can add a machine CRD, and machine controller will figure that out and create a new node, and it will join in your cluster. So
yeah,
most of it.
Cool. Yeah, the machine controller respects most of the spec right now. It's not terribly good about updating the status. I think that's going to be more feedback for the API as we get into these edge cases and have to update the status and provide meaningful information to clients. Right now, every update is just treated for a complete simplification that I don't expect to last terribly long. Every update is just actuated with a replacement of the VM in GCE. So we don't do in-place upgrades of the kubelet, which would be, I think, pretty easy to bang out. Feng is actually working on, I believe, he can correct me if I'm wrong, working on actual upgrades of the control plane based off of the control plane definition. If you bump the version, we can upgrade that using kubeadmin upgrade. The machine and node objects do get linked, or at least that's in a PR that'll get merged soon. And yeah, we have a pretty, I won't say near complete, but we have a pretty functional demo at this point to exercise all of the types. And I don't think that anything has been found breaking in them. But the functionality is limited. Like we can create a cluster and you can upgrade nodes or upgrade the machines, the kubelet versions, and upgrade soon the control plane, but not a whole lot else unless you start drilling into like component config and versioning that. But I don't know how many components are actually using component config right now. That's kind of forward looking in our API, but I don't think that the implementation is there now for all of the components. Cool, am I missing anything? Oh, we also have examples for, we have a client-side implementation of a machine set for people who really want machine sets. And I really want machine sets, but I really wanted the API to just start with machine before we reason about sets and make sure that we fully understand them. But if you want to play around with machine sets, our installer right now, if you want to specify multiple machines, it's kind of unideal because we don't just have a count that you can change from 1 to 3 or something like that. We have to enumerate every machine that you want to create, but you can just create one node and then you can use the client-side machine sets, which is just a CLI that allows you to specify a label selector that should identify the set. So whatever arbitrary label you want to match on, and then you give it a number of replicas and it will scale them up or down, just creating machine objects. And the machine controller does actuate them correctly. So you can use the installer, just create a simple master node and then scale up your node set pretty easily. Is there anything else that I'm missing that people have been working on that they want to talk about the current status of?
So I have been working on generating like clients and everything, informers, listers and asset and everything, and I got it running because currently we have like several clients, and we need code generation for that in order to get everything up and running. One issue that I made a pull request about this was that the current group version is cluster-api.kubernetes.io. and this is not working with the current implementation of the code generator in Kubernetes. So I suggest we just change it to cluster Kubernetes IO if it's okay. And yeah, if everything is okay, I'll just make a pull request tomorrow for the command generation with everything with scripts. And so, yeah.
Nice. Yeah, I picked that completely arbitrarily, and I'm more than happy to replace that. It was meant to be a placeholder because I didn't really know what to call it. Is it the hyphen that's getting us in trouble that just wants?
The last hyphen. If for example your group is example.cluster-io, cluster-API, it's working. However, if it's in the last name, then yeah, everything is broken.
Okay, interesting. Yeah, I have no objections. I don't know what it should be called, but awesome. I think Feng had maybe handwritten, maybe this was generated, but we do have a client checked in under cluster API/client that or I should say a few of our components are using right now. But if we had proper generation, that would be amazing. That would be really cool. So thanks for taking that up.
Like, you can impersonate anybody if you're on the,
I'm adding this to the agenda, but just maybe of interest to you, Martin. I'm also in the process of merging the machine and cluster types into the same group, all under the same cluster API, so there might be a little package structure change there that you might run into.
It's no problem. The main problem was getting rid of the core Kubernetes repository, which was causing a lot of pain, especially during the upgrade procedure. Yeah. And also, yeah, some problems with that, but I managed to solve them, at least on my machine.
Yeah, but just as an FYI, hopefully later today, both the machine and cluster type will be in the same package and API group.
On that, why are we doing that? In that, do we really want to tie them together?
Why would you not? This is all part of the cluster API.
Well, my argument against would be that the machine's API is fairly uncontroversial, very likely to make it into a release. The cluster API seems much more controversial and something we're likely going to have to iterate a lot more on. I feel like we could get the machine's API into 1.10, but the cluster API is like 1.20. Which is an exaggeration, right? But you know what I mean, like not 1.10.
I guess I understand that, but this is also not really tied to the major Kubernetes releases, since this is kind of outside the Kubernetes release cycle.
Yeah, I mean, there's definitely a like, we have to figure out how we do things outside of the Kubernetes repo that are still like integrated into the releases. Like as a Kubernetes project, we have to figure that out. But I mean, I still think that it is likely that the machine's API will go to beta much faster than other objects. Is that fair?
I'd say that's fair. Would it be fair to say that one of the types can graduate from alpha without the other?
Fine. I guess so. I don't know. Yeah.
Like if the cluster API was still under debate and no one could agree on it, I would be fine with having an alpha that had cluster and machines and a beta that just had machines. I mean, yeah, okay. I'd take that back. I wouldn't be happy. I would understand though.
Yeah, I'm just like wondering whether we should. Yeah, I'm just wondering whether it's a good idea to tie them or not. I don't know. What do other people think?
Yeah, I'm interested to hear other people's opinions.
Silence, crickets.
Maybe you could address your major concerns with the cluster API at this point.
Yeah, sorry, I missed the first bit. I think my main concern is that there is this component config, which is in this weird state, like it's been around forever and isn't moving particularly fast. I think that's fair. I don't think anyone that works on it will object to that characterization. I think some of the stuff in the cluster API is likely to overlap with the scope of the component config work.
Yes.
I like what you did now, which is like there are these handful of fields which do span multiple component config objects, specifically the CIDRs and the DNS name, and that is a problem in component config.
And they do have real impact on how you install, not just flags you can tweak later.
Yeah, yes. So I like what you did in that you effectively pulled out most of component config, or most of the stuff that's in component config, and that makes sense to me. It is going to be, it's going to be the one that's has more. I feel like for example, like let's take kops for example. I feel like kops can adopt the machines API almost immediately. I feel like GKE can adopt the machines API almost immediately. I feel like other people, I don't know, like Azure could adopt it, right? I feel like adopting the cluster API will be more work, and it will be less. It will be more work, and I don't know that will happen as quickly.
Can I ask a completely naive question about the API? So I think I understand some of the ramifications, but I'm hoping someone can summarize like all of the ramifications of having machines and cluster either be together or separate. Because I see it like we have different versioning, which is totally fine to graduate one independently of the other to beta or GA or whatever. We have the ability to enable or disable them in the API server via runtime config separately if they're in separate groups. But are there anything else that, like any other guiding principles of whether they should be together or apart, or functionality that is easier if they're together or apart?
As far as being together, I think the intent is at least to use them in conjunction. And as far as their like design, they should be designed with consideration for each other so that they work well together. And currently, as it stands, they're technically registered under the same API group. They're just structured, like code-wise, in different packages, which is what I was trying to correct.
Got it.
As far as for keeping them separate, you could, as Justin mentioned, you could develop them separately, have different beta graduations for them. Conceptually, they move a little further apart, but as far as like technical implementation, there's no real like limitations on how they use. You can do cross-reference API object references if need be. I think it becomes a little tricky if you start wanting to mix versions. Like, does V1 work with V2 all that well? Do I need V2 of both?
Also, technically, machine object can be abstract out, like basically one layer below the Kubernetes itself, right? So I'm not sure. In the long term, do we want to like basically allow this machine object to support other type of the class, not just Kubernetes, maybe other application workload to be also be useful for the machine object here?
Well, I think Chris mentioned something that did resonate with me, which is like if you start revving the versions completely independently, then you have all these problems of they are kind of related. We actually have a pointer from one to the, or maybe it's not a pointer at this point, but we do have expectations of when you create a machine that is a master, it will use the control plane definition for installation and reconciliation. So it's tougher to reason about, well, I'm using V1 Alpha 1 control plane, but I'm now on the GA version of machines, and do we fully support the old beta version of machines and alpha version? So I think a reasonable path, it sounds like, is keep them together, but if we want one to move to beta without the other, we could release a V1 beta one that just has machines but doesn't have control plane there yet, or it also includes the alpha version of the machines or something like that, but always having them tied together kind of makes sense to me, because then you don't have the combinatorial explosion of supporting the cross product of the two. I guess that makes sense to me, but I don't know what other people think.
It's okay. I think it'll be confusing, but I think we'll survive it. I think that I was just thinking like the one technical thing that I'm aware of is if we do an aggregated API server, I don't think you can split so each API server that you plug in has to handle a name, a version with a name. So you can have a different one for V1 Alpha 1 and V1 Alpha 2, but you can't have one for machines and one for cluster, I think.
Yeah. And also going forward, just conceptually, we were having the machines API being able to create masters, and without some way to plug in control plane information, I'm not sure how much graduating just a machines API to beta without cluster specific stuff would basically limit it to non-master machines, because master and control plane setup would have to still be specialized or completely contained within that machine's cloud provider, in which case.
Well, it's not it's the machine provider, right? So like if GKE had a machine provider, it could consult the GKE data, and if COPS had one, it could consult the COPS data.
Yeah, the machine provider has some private information either in the provider config in the machine or some external database. It would be awkward, but still could be done. But graduating the machines to beta without the cluster mainly just makes it useful for node creation at that point.
Oh, I mean, we can certainly do it. If we discover it's a huge mistake, we can.
Yeah, I mean,
we can make a lot of mistakes with V1 Alpha 1 and just correct it.
Yeah, the reason the control plane is so minimal is because it is so controversial, and you made very good points about not duplicating component config. And as a straw man, like the only settings I have in the cluster level right now are the CIDRs that I think almost every cloud provider needs to do something special for, so it makes sense to put in the general config. And then at the machine level, I don't know if you noticed, but I moved the version out of the control plane and put a control plane version field in the machine level. So each master can now have a different control plane version that it's running.
Cool.
And those are basically the only control plane settings there now.
I would encourage us to, I don't know, I don't want to like express too much frustration, but like the component config API has been going on for a long time, and it feels like we should make it happen or give it up, right? And I feel like we should make it happen, but I don't know who's working on it.
I agree with that wholeheartedly.
I mean, there is progress, right? Like I think kubeproxy has it now. Is that true? But you know, like it is gradual.
I think kubeproxy and kubedns have it. I don't know where to go with this. I will probably run this up the flagpole to get who's an owner of it and find out. And I can.
I mean, and it might be we take on the component config as like we embed it in the cluster API and we say, hey, this is going to be the component config or whatever.
I mean, that could be it. I'm not particularly happy with the current component configs that live there, but
I mean, I think that's fine, right? Like the idea being that like, oh, what needs to happen to get this to work is like, well, it doesn't work right now for X, Y, Z reasons. So let's fix X, Y, Z, and we'll do that in this experimental project, and then we'll merge back into master, as it were.
Yeah. Anyways, I'm going to figure out who owns the component config efforts for the various teams.
That'd be great. Thank you.
Do some lobbying.
Okay.
Cool. So we already talked about client generation for the APIs. That's awesome. Can't wait to see that. And merge types. We're out of agenda items. I was hoping that Chris Nova would make it. Supposedly, I don't want to put words in her mouth, but she's working on the Azure implementation for this. So we would have side-by-side GCE and Azure as a pretty good test of the types right now. But anything else anyone wants to interject before we end it early?
We're also currently working on AWS implementation because that was lacking, and our clusters are mainly on AWS. And we've been working internally on API, which is almost exactly the same as the machine API. So, and even the actuator that we currently use is some of the same as what we have here. So, hopefully, we'll be able to contribute soon with the working AWS implementation for it.
Awesome. If people want to follow those efforts, could you put a link in the meeting notes to whatever repo we should be watching?
Oh no, we should just try to get into this repo. Just as another provider into the cloud thing.
Okay.
Into the cloud folder. So yeah.
Cool. Nice. If there's nothing else to discuss, we can get 15 minutes back.
Just a quick note on using kube deploy. As long as everyone's aware that this is meant as a temporary location and not a permanent deployment, and hopefully cloud provider stuff, specific stuff, will be split out into separate repos later on. But just note that it's not a long-term solution. Hopefully.
Yeah, and I hope this was addressed at some point, or people have realized, but the code that we're putting in there is so prototypey. It's we've been doing a lot of self-merging. Hopefully that hasn't scared anyone. We're just trying to, it's really just an exercise in testing the types. And those are the real deliverable, I think, is making sure that we have solid understanding of what the API should look like, and having a functioning prototype is just a really good exercise for that. But a lot of that is just going to be throwaway code, or hopefully graduate into something more stable and production worthy than just
and fully reviewed.
I have one. Oh, sorry. I don't know if that's noise or something. I have one question, which is how probably this, I could answer this myself, but how does the bootstrap work today in terms of where do I create the cluster API object for the first thing? Does that make sense? Does that question make sense?
Do you want to handle that, or I can talk about it?
Like, I'm not very clear about the question.
Can you just walk through the bootstrapping that we do in the installer to get things going, like the overall workflow?
Oh, so you need to specify the cluster object. Like, you need to say in a YAML file, this is my cluster specification. So, and the installer will read that and create a cluster for you.
Maybe I'll drill into that. Okay,
so there's yeah.
We have a client-side installer. It's all Go. It used to be, for expediency, we just vendored in Kubicorn and took advantage of that. But we, I think just as of yesterday, moved off of Kubicorn because there were some hurdles to get over for the functionality we needed. But reads in some YAML files to express all of the machines that you have and the cluster object, and then pays special attention to the master that it should create and the cluster object, creates your very first VM. And once the API server comes up, it injects all of those objects directly into it. And the master comes up with a machine controller, and the machine controller rectifies everything else. So it'll create all of your nodes.
Cool, so that makes a lot of sense. And so yeah, we deliberately don't specify where the bootstrap thing happens so that you can plug in GKE or like a management Kubernetes cluster, or like Kops has an S3 hack, which I'm not terribly proud of, but it works. And there are, okay, that makes a lot of sense. I understand. And we basically bring up just the master and then inject from there. I like it. And also that will work well with component config if we ever get there. Cool.
Yeah, we brainstormed a lot of things about maybe starting a local API server, and then even reconciling the master from that and completely bootstrapping from a very minimal set of things, kind of like Bootkube does. But this seemed very simple for the prototype right now, and it actually works so far. But we can always revisit.
And I guess the idea is that once you bootstrap, you will no longer use your bootstrap file, so you don't write back. Is probably the typical approach.
Right. At that point, the authority is the API objects in the API server. Yeah.
Cool. That makes sense.
Nice. Okay. Anything else? Cool. Well, thanks everyone for joining. I'll upload this video in a bit, and see you all next week. Bye.